Alright, in this video we're going to start by talking about parallel and perpendicular lines. Now, one way to tell if two linear equations are parallel or perpendicular is obviously to graph them. But you can also tell without having to graph them. The way you tell is by looking at the slopes. Parallel lines will have the same slope. For example, the lines y equals 2x and y equals 2x minus 1 are parallel lines. If lines are perpendicular, their slopes are going to be opposite reciprocals. So for example, you might have y equals 1/4 x minus 3, or you might have y equals negative 4x plus 1. These are opposite reciprocals. Opposite because one's positive, one's negative. Reciprocals because 1/4 and 4/1 are reciprocals. But what if they are not written in slope-intercept form? Well, in that case, what you're going to have to do is you're going to have to make them be in slope-intercept form. For example, if you see something like 8x minus 6y equals 42 and negative 3y equals 9 minus 4x. Well, in this example, what you're going to want to do is get y by itself, so y equals all the rest. And on this left one, I'm going to start by subtracting 8x from both sides, which gives me negative 6y equals negative 8x plus 42. But I want y by itself, which means I have to divide everything by negative 6, because that cancels this out. So I get y equals 4/3 x minus 7. Now I look at the other one, and to get this one by itself, the only thing I have to do is divide by negative 3. So I get y equals negative 3 minus, or plus, I'm sorry, negative divided by negative is positive, plus 4/3 x. And when I look, my slopes are the same, which means these lines are parallel. So let's look at an example where they are perpendicular. Okay, if we have negative 2y minus 6 equals negative x, and 6x plus 3y equals 12. Okay. I'm going to start by adding 6 on this one, which gives me negative 2y equals negative x plus 6, and then I divide everything by negative 2. Which gives me positive y equals positive 1/2 x minus 3. Over here, I'm going to start by subtracting 6x from both sides, which gives me 3y equals negative 6x plus 12. Then I divide by 3, which gives me y equals negative 2x plus 4. So I look at my slopes. One's positive, one's negative, and 1/2 and 2 are reciprocals. So this is perpendicular. Now it is possible for our lines to be neither parallel nor perpendicular. If that happens, well, it can take one of many different forms. So it might be that you have slopes of maybe negative 2 and positive 2. They're opposites, but they're not reciprocals. These are neither parallel nor perpendicular. If we had something like, let's say y equals 1/2 x and then y equals 2x, these are neither as well. Because while they might be reciprocals, they're both positive. So they're not opposite reciprocals. But either way, when you're trying to check whether they are parallel or perpendicular, you do need to put it in slope-intercept form and then compare the slopes. So now let's talk about intercepts. An x and y intercept are where they intersect the x and y axis. So as an example, we might have a line intersect here and here. Okay? This point is the y-intercept because this is where it intersects the y-axis. So the y-intercept is the point 0, 4. Notice your x value is 0 because it's at 0 on the x-axis. This is your x-intercept because that's where it intersects the x-axis, and in this one your y value is 0. So negative 3, 0 is the intercept. But your x and y intercepts are where they cross the x and y axis. Where the y-intercept is, x is 0. And for the x-intercept, y is 0. Now I'm making this point because that is important when you are trying to find the intercepts algebraically. Because it's easy to find when they cross at a whole number. But what if you have a line like this? When you go to connect the dots, it intersects somewhere right there, but where? You can make an estimate, but that's all it would be. If you need an exact amount, you have to use algebra. So if you are trying to find the intercepts with algebraically, for the x-intercept, what you're going to do is you're going to plug in a 0 for your y. For the y-intercept, you plug in a 0 for your x value. So let's look at an example. Let's take the equation, let's take the equation 3/4 x minus 1/3 y equals negative 2. If I want to find the x-intercept, I'm going to replace the y with a 0. So that would give me 3/4 x minus 1/3 times 0 equals negative 2. Well, multiplying by 0 just gives me 0, and when I subtract 0, that's not going to change anything. So I just have 3/4 x equals negative 2. Then to get rid of the fraction, I multiply by the reciprocal. This cancels out the fraction over here, giving me x equals negative 8/3. So the x-intercept is negative 8/3, 0. For the y-intercept, I'm going to replace the x with a 0. So I would have 3/4 times 0 minus 1/3 y equals negative 2. Well, again, multiplying by 0 just gives me 0, so bringing down what I have left is negative 1/3 y equals negative 2. Multiply both sides by the reciprocal, negative 3 over 1, or just negative 3. And this leaves me with y equals positive 6. So the y-intercept is the point 0, 6. Do another example. Let's take 4x minus 2y equals 5. Okay. For the x-intercept, I'm going to place the y with 0. So 4x minus 2 times 0 equals 5. Bring down what I have. This is just 0, so all I can bring down is 4x. Divide off the 4, and I get 5/4 for my x. So the x-intercept is 5/4, 0. Y-intercept, you replace the x with 0. So 4 times 0 minus 2y equals 5. This is just 0, and when I do 0 minus 2y, I get negative 2y equals 5. Divide by negative 2, and I get y equals negative 5/2. So the y-intercept is the point 0 and negative 5/2.